So, shall I jump into it?
Yeah, please.
All right, wonderful. Thank you so much for the invitation to speak with you today. I'm sorry I can't be there in person, but this is life at the moment, right? So I'm Rebbeca Fiebrink. I'm a reader at the Creative Computing Institute, a pretty new interdisciplinary creative technology center at University of the Arts London. And despite the title, I've actually been collaborating with creators for something more like 13 years, but that sounded like an unlucky title, so I've titled it a decade. So I've been working with creators in music and a variety of other creative domains for about 13 years now, and using that to inform both my research and implementation of a lot of creative technology software. A lot of this software uses machine learning in some way. Wacinator was the first, and I'll talk about that a bit. Also, Interactiml and RapidMix, which Michael Spashinsky, who's here, has worked on. Also, Mimic, which Chris Kiefer has been really central to. Another project called Sound Control, which I'll mention. But there are also projects, including some not here, that aren't really about machine learning, but go off in different directions, such as Digital Fauvel, which was an interactive medieval manuscript project. So in this talk, I've got two parts to share with you today. The first part is some reflections on how working with creators over the last 13 years, how this has transformed my understanding of what machine learning is good for and how to make it usable. And hopefully there's interesting bits here, whether you've been using machine learning in your own work for a while, whether you really don't care about machine learning, but you're doing other kinds of creative stuff. Hopefully it's interesting to everybody. And then part two is reflections on things I've learned about establishing and maintaining effective collaborations. And so this is something that, probably everybody here has their own perspective on. It sounds like most of the people in the room have been on either a technical side or a creative side, or both, in some kind of collaborations in which you make a thing. I'm going to share my own perspective, and maybe this will lead to some interesting discussion later on. All right, so part one, how working with creators has transformed my understanding of machine learning. Now, I came into this space as a computer scientist. I've an undergrad and master's and PhD in computer science, but I also came to it as a musician. I've got another couple of degrees in music. I'm a flutist originally, and during the beginning of my PhD, around 2005 or so, 2006, I got really interested in um, performance work with new musical instruments and new types of live performance technology. And at that time, there were just loads and loads of new sensing platforms that we could use to get information about how performers were moving or sounding on stage. And it was becoming easier to use things like Arduino, easier to use things like audio and cameras in real time. And of course, there's been a continuing explosion in sensing devices and platforms since then. So I was entering this space at a time when getting data about what people were doing or what was happening in the environment was really easy, but interpreting or mapping that to decisions over, say, what sound happens if you're building a new musical instrument, this was really difficult and annoying. And I came into this as a computer scientist who'd already been using machine learning in different types of problems, recognizing that, actually, machine learning is a really good fit for this. In particular, there are a bunch of problems that fit a basic sort of pattern where some simple machine learning can be really useful. So if you're building a new musical instrument, you can think of this as trying to train a computer decision-making process where it sees something that you're doing, maybe a hand gesture in front of a camera, and makes a decision about what sound to play as a result. Or if you're doing a live audiovisual performance, maybe the computer is listening to the sounds that an acoustic or electronic musician is playing, and then using that to make decisions over, say, parameters of a live visualization. I've also done work for quite a while now with game designers and interaction designers, where maybe it's not about music, but it's maybe about understanding what gestures or actions somebody is taking in the world and using that to change what maybe a video game avatar does or change some other behavior in VR. And if you know anything about machine learning, you're going to look at these kinds of problems and say, yeah, actually, this is a pretty good fit for supervised learning, right? Where our goal is to build some model function for prediction, where we take some sensor data in and we output some decisions or some parameters that could be used to control maybe max MSP or unity or some other kind of real-time process. All right. And of course, those of us who are programmers working in music or sound, we've programmed these models ourselves for many years. This is something we do quite frequently. And you probably have a good idea of, what are easy models to build and what are hard ones. And the nice thing about supervised learning is that we can use a supervised learning algorithm to build this model for us from a set of examples. So if I'm building a hand gesture controlled instrument, I can give it examples of hand gestures and sounds, right? And from that, it'll build a model that tries to encode that relationship or that mapping. All right, so this was my motivation to get into this space. And at this time, again, 2006, 2007, supervised learning was being increasingly used all over the place in computer science, in different application domains. It had not been used very much in music to build these kinds of systems. And it wasn't because we needed new algorithms. It was actually because, frankly, there weren't any usable tools out there for musicians. So I started with the question of, how could this process be made more usable for musicians? And so that's when I began making the tool that ended up being called Wekinator. I began with a series of participatory design processes with composers, people building new musical instruments and new interactive technologies, and then following individual composers who thought it was interesting, following them up with interviews and observations over a more extended period of time. That led to the first version of the software and a paper that I published way back at NIME 2009. Since then, I've had lots and lots of close collaboration with a variety of creators in music, art, design, games. Also, I've interacted a lot with students. I've taught thousands of students of how to use machine learning with Wekinator and with other tools, and I've learned a lot from them. So this work really continued, influencing really strongly the second version of the software, which I released in 2015. This version has had something like 45,000 downloads last time I checked. It's been become really popular. It's used in teaching and professional art, music design practice, as well as lots of student projects around the world. Because of some of the really exciting findings that I'm going to share with you, this basic approach of making machine learning usable and trying to understand where it fits into creative practice, this has informed a bunch of other research projects, including the ones that I mentioned at the beginning of my talk. And I'll come back to a bunch of those later as well. I was actually, when they asked me to give a keynote today, they said, hey, would you mind talking a bit about themes in your NIME 2020 paper with Letitia Tsunami? So I'm going to talk about some of the stuff in that paper, but that is a co-authored paper, and a lot of it is actually written in Letitia's voice in the first person. So I don't want to walk all over that. I can't duplicate her voice in that work. So I would recommend that if there's content here that seems interesting to you, definitely go look at that paper and see what Letitia has to say herself, because she's brilliant. And she's somebody who I've worked with for something like 8 or 9 years now. And her creative vision and her practice has really informed the way that I build my tools and the way that I think about this space. All right. I want to just give you, for those of you who aren't familiar with Wekinator, I'll give you a couple examples of things that people have built with it, and then I'll jump into the sort of surprising findings and changes that these creators have ways that they've changed the way that I think. So first, I'll show you a quick clip of a video with a composer named Michelle Nagai. She was one of the first people ever to use Wekinator. She was one of the people in the participatory design process that I launched with composers when I just was thinking, okay, I feel like supervised learning is useful here. I'm not exactly sure how to make it usable, and I don't really know what people are going to do with it. Michelle was one of those people who really shaped my thinking from the beginning. And she ended up making very early on this instrument made out of tree bark, and it has light sensors embedded in the bark, and she plays this by casting shadows over these sensors. And so she's used Wekinator here to make the mapping between this, I think it's about a 25-dimensional input, 25 light sensors, from that to a whole bunch of real-time control parameters in Max. So just, you can have a listen and listen to her speaking a little bit about it too.
Basically taking the data and it's comparing it to examples that I've given it in the past of relationships between certain data and certain gesture and a certain sound. So if I train the machine learning software that when I wrap my arms around the instrument and the sensors register less light, it makes a particular kind of sound, and then full light, it makes a different kind of sound. So I give it all these examples in the training process, and then I run it and I see what happens, and it takes the data that's coming in and says, oh, that looks just like the data, or that's similar to the data that she has when she wants this sound. So it sends that message to my sound processor, and the computer outputs that sound. So it's just another way, basically, of mapping gesture to sound.
Okay, so that's Michelle. And then the second video I want to show you is from about 5-6 years ago now. This is Letitia in at the NIME 2014 opening concert, playing an early version of Spring Spire. And she talks a lot more about the same basic instrument and the way that it's evolved in our NIME 2020 paper. So here's a clip of Letitia. All right. And as I mentioned, Wekinator's been used in all sorts of other projects, other music projects, like Alex Murray Leslie from Chicks on Speed made a really cool, like, high fashion shoe controller. There's a startup called Voclia that used Wekinator to do early prototypes of what's now a pretty cool product that allows you to sing or beatbox and then translate that to input into a DAW. And then a bunch of non-musical projects, everything from digital puppetry to crazy art projects, to happy little robots and more. All right, and of course, as I mentioned, I've learned a lot, not just from creators in this space who do things and people I follow up with, but also my students and the really cool student projects and difficult student questions that come out of people working with Wekinator and related tools. All right, so that's really the background. Let's jump in now. I've got 3 lessons to share with you, 3 things that I've learned about machine learning from these creators over the past 13 years. Number 1 is that making machine learning usable isn't just like spreading peanut butter over the top of a computational system. There's a saying in user interface design or usability that usability isn't something you can just slap on top, right? It's not about making a friendly looking GUI with really nice color schemes and good use of white space. Yeah, that's kind of important, but it's really not enough. Likewise, in the machine learning case specifically, it's not about dumbing down machine learning. It's not about hiding math. It's not about hiding complexity necessarily to say, oh, those poor musicians, they can't program. Let's make everything simple. It's absolutely not about that. If you look at the Wekinator interface, this is what the current version looks like. It's simple-ish. It's not particularly inviting, and it certainly could look a lot better. I'm not any kind of graphic designer. But there's been a lot of really tough decisions and a lot of changes over time about, what I show to people and what I don't. And then even more difficult fundamental decisions about how do people interact with these algorithms in the first place. Because if I hadn't gotten that right, we wouldn't have something that, was usable no matter what kind of user interface we plopped on top. So let's talk a bit about this. This was actually one of the first and most important things I learned from the beginning of working with the participatory design process with composers. So, okay, let's imagine you're building a new musical instrument. Again, back to the easy example of maybe you move your hand and the sound changes. Um, the first big difference between your task of building a machine learning model and the way that a computer scientist would generally build machine learning models in the real world, or the way that you'd be taught to build machine learning models in a computer science class, the first big difference is that you don't start out with an existing data set, right? And even if somebody else had built a data set somewhere of hand gestures paired with sounds, it's probably not going to help you because you probably have different ideas about what gestures you want to use and what sounds you want to use, right? So the first thing you have to be able to do in this applied machine learning process is build a data set. Next big difference is that, in computer science, when we talk about um, you've built a model, how do you evaluate it? There's a bunch of different pretty standard quantitative approaches where you might get numbers out, giving you accuracy information, for instance. If I, said, all right, we've built you a model for this instrument and it's 95% accurate, like what does that even mean, right? That's not actually that helpful, because where are those 5% of mistakes? Are they on gestures that you're never really going to do in performance anyway, or are they on gestures that, constitute the really important dramatic beginning of your piece, right? You really care about where those are, for one thing. So the second thing that I ended up making possible within Wekinator itself was actually just trying out models in real time and experimenting with them. And then the third big and perhaps most dramatic departure from a computer science approach to machine learning is that if you say you're trying out this model and it doesn't do what you want to do, right? You have your hand tilted a little bit and it makes the wrong sound. Actually, one of the most sensible things you can do as a practitioner here is go back to your training data and give it more examples and say, all right, when my hand does this, don't do that thing that you're doing currently, but make this other sound, which is the one that I want. And so that's completely sensible in this context, but this was really not something that was done in 2007, 2008, 2009 when I was beginning this work. Today, this is used much more commonly in a variety of machine learning, applied machine learning contexts that share characteristics of the kinds of things that I'm talking about here. And this is in human-computer interaction, we would call this now interactive machine learning, this set of interactions that are really not standard. They're not really part of the way that computer scientists would think about how you build and test and refine a machine learning system. But they're sensible here. And so when I built Wekinator, that was the biggest practical difference that I had to learn about, that I had to kind of work through and reason through with the composers I was working with, to figure out that, yeah, this is the way we have to do it. And all of this practically needs to be within the same user interface. As I mentioned, I've been doing a lot of different projects since Wekinator. One of them, currently, I think we've got a really nice version of this out right now, but the project is wrapping up soon. We're going to have even better versions for Unity and Unreal by the end of the summer. This is called Interactiml. So this is an interactive machine learning environment for game designers and VR designers. And again, we've had to ask really tricky, challenging, unanswerable questions about, like, what abstractions do we employ and how do they interact with each other. Interactiml is, it is a sort of data flow visual programming environment for designers and programmers, and it allows you a much lower level view and a much different visual representation of what's going on compared to Wekinator. And I really like a lot of things about it, but we're kind of building this from scratch in many ways and trying to come up with answers to questions like, is a training data set like an object here? Do we, how do we visually represent the components that people are going to work with and tell people how they can connect and not. What kind of black boxes exist in this system? Machine learning, typically certain things you just hide from people, even in, programming APIs like Keras or TensorFlow. Do we want to hide the same stuff here? Do we want to hide different stuff? Do we want people to open things up? Right? So there are big questions, again, about the fundamentally how we structure things in order to make it usable. On the really other end of the sort of machine learning expertise and technical expertise spectrum is a project called Sound Control, which I finished up a couple years ago. Here, the users of this software are music teachers, music therapists, and kids. Especially kids they work with have a lot of different types of disabilities. And pretty much nobody in our group of users, target users for this software, has much expertise with anything. Like, some of them kind of use GarageBand, and that's it. But again, we've got to answer these questions about, what are the abstractions and black boxes that we employ? How does the software connect to existing tools and ways of working? And I mean connect in multiple ways. Like, can we actually connect to GarageBand? Can we connect to the MIDI keyboards that they have? But conceptually, how do we connect this to the musical knowledge that the teachers have, to the musical preferences that kids have? And so we ended up doing things like, it's a completely redesigned user interface with some redesign actually in the interaction with algorithms compared to Wekinator, even though they're very similar pieces of software. And we also, package it up with a bunch of music kind of right out of the box, including sounds that kids like, lots of animal sounds, lots of fart sounds. It turns out kids really like fart sounds, right? So that's when we think about usability. Again, it's not just making things pretty. It's really deeply thinking about what are people going to be doing. All right. Second thing that I learned, and this was probably the hardest for me to learn, but also the most exciting as a researcher, is that computer scientists are wrong about a lot of things. And we probably all know that, but in this context, especially, computer scientists are wrong about things like what machine learning is good for, right? If you ask a computer scientist, what is machine learning good for? There's a sort of correct answer, which is that, it's good for things like finding patterns in data, making accurate predictions, generalizing, taking knowledge from large data sets and generalizing to new data that it hasn't seen before. And none of that is like wrong per se, but it turns out that in creative contexts, including music and others, whether we're talking about supervised learning or generative learning or other things, actually those sorts of properties can be relatively unimportant compared to all the other things that it has to offer. So again, the past 13 years or so has completely changed the way that I think about machine learning's utility. What is machine learning good for? Let me give you a quick tour of some of the ways that I think about it now. So for one thing, creating systems from examples rather than coding enables faster creation. It enables faster change and iteration, right? What this means is that machine learning can support rapid prototyping and exploring many different ideas before you run out of time and have to have a finished implementation of something. Right? And those of you who are working in any sort of creative domain know that this is super important. And this is not what machine learning is built for, but it's a theme that's come up again and again when talking to creators and saying, why are you using machine learning tools? Often it's because, in a given amount of time, they can explore the possible design space more broadly, and they end up making something that they're just happier with in the end. Related to this is another phenomenon, which is that when you are communicating about embodied practices or about tacit knowledge, these are things that are really hard to do in your native language, right? And especially hard to do in math or code. So if you think about, how somebody paints a picture, how somebody plays a violin, how somebody rides a bicycle, these are things that, we can be very good at, but even experts are going to struggle a bit to communicate in ways other than showing you examples, right? And of course, teaching in these domains often is done by example when it's teaching between people. And so machine learning as a set of tools that allow you to communicate to a computer via examples rather than via explicit rules or equations, actually it can be just much better matched to understanding, in a sense, or responding to actions or tacit knowledge and so on, right? So this is another theme that's come up again and again. And when people talk about what machine learning offers them that something like programming does not, even for people who are expert programmers. Machine learning can also make technology creation more inclusive. If we think about this process of essentially designing from examples, designing from data, this means that if you set up your design tools right, people don't have to have any programming expertise in order to make completely new bespoke systems. Likewise, people can take existing systems and personalize them in ways by adding examples rather than by trying to code or futzing with a really complicated set of menus and so on, right? So this is really exciting. It's been key to enabling me to teach people about interaction design when they don't have any coding experience. It's been key to a couple projects that I've done, including sound control, which I mentioned, and another project here called Sound Lab, where we've worked with people in the community with disabilities and enabled them to build things for themselves, right? To say, hey, I want to move this way. I want these sounds. I'm going to go make that for myself. And the last thing that I'm going to share about what machine learning is good for is it can provide access to discovery and surprise, right? And this is quite far from, I think, the intentions of the creators of the sort of standard machine learning algorithms that Wekinator uses, or that most creators using machine learning today use. But it's super important. So if you think about one way to get surprise out of a supervised learning algorithm, such as the ones in Wekinator, it's pretty easy to get surprised. If you give a training data set, imagine these are sounds, if you will. If you give a training data set pairing different gestures with sounds that are all quite different from each other, and you use a type of algorithm called regression, actually you can make it really easy to make it possible to get sounds out of that model that you've never heard before, right? So if you give it inputs that are like those in this training data, you're going to hear sounds that are probably pretty similar to these. But as you go beyond those or in between those, you're going to hear sounds that might be totally beyond or sort of interpolating between sounds in your training data, depending on how you set up the system. So this can be super powerful. This can be really fun. One of my favorite quotes from Letitia, when she has talked about using Wekinator to build Spring Spire, she says, in a way, you don't want the instrument to perform like a well-trained animal circus. You kind of want it to be a little wild, and you want to adapt to it somehow, like riding a bull. I think the machine learning allowed more of this fun of exploring instead of going, I have to have a result right away. This thing is going to do that, and leaving it at that. All right, so I think hopefully I've convinced you machine learning is good for a lot of other things beyond what you might read in an ML textbook. And that has really exciting, powerful implications. So I think there's a standard computer science way of thinking about how people should effectively interact with machine learning algorithms to build something, test it, and refine it. And a lot of the differences, when we look at how this might change in creative practice, come from the role that data is playing. So in computer science, again, as I suggested, data is treated as ground truth. Data is something that you collect from the world, and it's sort of your one and only portal into some phenomenon that's happening that you don't otherwise understand, right? In creative practice, on the other hand, sometimes data is a way for people to communicate their ideas and their intentions to a computer, right? So if I'm building a musical instrument and I give it a training data set of hand gestures and sounds, I already understand my intended relationship between hand gesture and sound, right? That's not a mystery. I'm not trying to uncover the truth of that through machine learning, but I am trying to communicate to the computer what my design goals are, right? And so this again, this needs to inform how we build machine learning interfaces for creative work. The most obvious example of this is that the sort of interactive machine learning workflow that I mentioned previously, where we actually change the data in order to change what the model does. This is a big consequence of that. But there are other consequences as well. Of course, in the last 10 years or so, big data, big data, big data has been the refrain of computer science, of machine learning, of a lot of industries that think that they can benefit from machine learning techniques. However, if your data is your interface to communicate what you want the computer to do, there's not so many benefits to big data compared to these other more conventional applications. And in fact, small data can be perfectly sufficient. It can be great. I want to show you an example from a project called RVAE. This is a project from my postdoc, Gabriele Vigliansoni, and he's been building generative machine learning systems, this one using a VAE, to generate rhythm. And a lot of the work that's out there that looks at rhythm modeling and rhythm generation, it's trained on really big training sets, right? Because the goal of a lot of these systems is to build a fairly general purpose model with the capacity to output all sorts of different rhythms. And that's, I'm not going to say that that's not an interesting goal, but it's sometimes not the right goal. And it can be an even problematic goal, right? If you think about what are the training data sets out there of rhythms? Well, a lot of it is sort of Western pop music. And as a result, even the sort of data structures that machine learning researchers have used to represent rhythm don't allow for things like, mixed meter, right? Which ends up being really important in a lot of other genres and rhythms from, non-Western cultures. And so Gabrielle's project, this RVAE project, really says, hey, let's do this the right way for building generative rhythm systems for individual musicians to use, where your goal could be to say, hey, these are the kinds of rhythms I'm interested in. We're going to place relatively few constraints on those. And maybe I just compose all these from scratch, or I curate them very selectively from a small collection. Then I can make an interface for myself to explore those rhythms and generate other rhythms that are similar to that. Because if I'm kind of playing music within a very niche genre, I don't want to switch to some other genre in the middle of my piece. Like, that's probably not interesting for me. And if it is interesting, maybe I train from both of those genres, but not something else. So here's an example of RVAE. And this is a system. You can try it out on GitHub. It runs in the browser. And you can train this from a dozen examples and get really nice results. So here we go. And as you see the mouse moving, it's sampling different places in the generative space of the model, right, in the latent space of the model. And of course, if we think about, hey, small data is actually not a bad thing, that opens up all sorts of other ways of thinking about machine learning that I think as computer scientists we're trained to ignore. I'm happy to talk more about that in questions if people are interested. All right, the third finding I want to share with you is that human learning, I think, is really key to effective machine learning. And so this goes even further beyond my lesson one, which is that we can't, add usability like spreading peanut butter on a sandwich. When I teach new students or I get new people interested in using Wekinator or other tools that I've built, their key questions are always things like, well, first of all, what can I build? How do I build it effectively, and how do I fix it if it's not working, right? And having a nice user interface can only do so much here, right? Having a nice user interface is probably going to be most helpful in allowing people to say, okay, here's the steps that I take in order to build something, and maybe here's some of the information that I need in order to reason about how to fix it if it's not working. But how do I know what's possible in the first place? And how do I start fixing bugs when none of the obvious things seem to do it? I've ended up addressing this challenge in a few different ways in my work. First of all, if you look at the Wekinator website or the sound control website or the Rapid Mix website, all of these have lots of examples, right? Examples are really key, both to sort of scaffold people getting started, to say, all right, well, if I want to connect machine learning to Max MSP, here's how you do it. Or if I want to connect it to an Arduino, here's how I do it, right? Getting people started more quickly. But this also, gives them a nice idea of what kinds of things might you do. I've got lots of examples of finished projects that people have. When I teach this to students, I show a lot about past student work. So this is one component, I think, of making effective machine learning tools for people is teaching them about these things that aren't about the algorithms at all, but about how you connect it to artistic creative practice. There's also, I think, a really important role to play in what I would say formal creative machine learning teaching. So over the last 10 years or so, as I mentioned, I've taught thousands of students in workshops, initially workshops at different music and art festivals, then ultimately at my university at Goldsmiths and now UAL. And then I also have a quite popular MOOC on Cadenze and a series of MOOCs that are including some in progress on FutureLearn. So one of the main reasons that I started doing this teaching was that I realized, look, people who are going to use machine learning in creative practice actually do need some machine learning knowledge. You can't just hide it all away. You can't just put it all in a black box. But also the kind of knowledge that people need is a little bit different to the knowledge that a computer scientist or a data scientist needs. So the existing MOOCs out there that are teaching people to think like computer scientists are not so helpful. People are just going to have to unlearn all that stuff the same way that I unlearned that stuff when I started working with creators. And so I have some of this. If you're interested in this, I've got an ACM Transactions on Computing Education article from a couple years ago where I talk about that in a lot of detail. One way to think about my goal when I teach people formally in classes, but also when I am doing participatory design processes with people in new projects now, is that I'm often trying to teach people like just enough so that they can do the wrong things for the right reasons, right? And again, because I had to unlearn so much of this computer sciencey way of thinking about my tools that was getting in the way of realizing what was really important to people and how to make it usable to people. I don't want to necessarily, continue forcing those inappropriate ways of thinking onto new creators or students who are using my tools. So let me give you an example of when this has been successful, for instance. So Letitia Sanami, as I mentioned, we've been working together for like 9 years ago now. She is an absolute expert in machine learning. She is a world expert in creative machine learning. She's been doing this longer than almost anybody else. And she thinks about machine learning in a way that's completely different from a computer scientist, but very well targeted to her creative goals. And so if you go look at the NIME paper, for instance, one of the things she talks about is her sort of this technique that she developed, which she talks about as varying a predictability index to shape the synthesis terrain of an instrument. And so synthesis terrain is her term for what is the space of possible sounds and possible movements through sound space in an instrument, in a mapping that she's built for Spring Spire. And a very narrow synthesis terrain would be a sound space where all the sounds are, quite similar in some way. And if she wants a sort of narrow or high predictability index, she can build such a synthesis terrain from a bunch of examples that are also quite similar, right? But then she thinks about sort of tweaking this predictability index by, say, adding examples that are quite different from each other, which are going to give her a much wider synthesis terrain, right? So this is absolutely a sensible thing to do, and arguably a sort of, first order principle that you might want to, teach future students who are thinking about how to tweak machine learning algorithms to do what they want. But she's gone far beyond this and developed a bunch of other more nuanced techniques, and I'm going to try to explain one to you here. So keeping this in mind, some of what she's doing when she's building an instrument or playing in a performance is kind of jumping into these big, wide synthesis terrains where there's a lot of surprising stuff, including sounds that she hasn't heard before. And she's kind of wandering around in this space using her gestures with the instrument. And then she says, oh, this is a cool sound. I want to explore this area of the sound space in more detail. She developed a way to do this that I'm going to try to explain to you. She calls this freezing features. So what we've got, instead of just one number going in from the springs to her machine learning models, she's actually got something like 36 numbers, right? And they're all being sent to a bunch of machine learning models in parallel. What she does at these moments where she wants to zoom in on the sound is she'll freeze most of these numbers and say, I'm just going to ignore what's coming in from the springs, from the sensors, and I'm going to let only a few of these numbers change. And that means that, if she was starting with something like this for her synthesis space, suddenly she's frozen this and she's said, okay, I want less variation in some ways, and I'm going to navigate this narrower space until I decide I want to jump back out to the larger world again and start exploring that. Right, so that's the kind of thing that's part of the practice that she's developed. All right, so I've got about 5 minutes left. I want to very quickly share some reflections on working effectively with creators in making new technology. The first one is, for me, and this is something that I really try to emphasize with my students, most important way to start if you want to make technology that's useful for other people and do research in this area, or just make stuff that has a big impact, is start with the right questions. I think the wrong question is, oh, do people like this thing that I made? Right? That's not super informative. There are a bunch of other questions that are probably more interesting, which if you start to answer them, even if imperfectly, they're going to really inform the way that you think about something, right? So what do people currently do? What might they want to do? A bunch of other options, and most of which I think can be summarized by this last one. What might I learn from other people that might change how I think, or how others think if my goal is to write a research paper and get it published? Second is that for me, using participatory and iterative processes have really been essential to provide the opportunities for the kind of learning that I've shared with you, right? So it's not about building a thing and then going and testing it with people at the end. It's about really getting input from a lot of different people, using a lot of different methods in a lot of contexts over a long period of time. So if you pick up a sort of standard human-computer interaction research methods book, I've used probably most of the methods in there in some way or another. Usually not in lab studies, which is sort of the stereotypical way that people think about HCI research happening, but in classrooms, in workshops, in residencies, in retreats. And a lot of my own work, we might start out doing things quite formally, or I'll do formal approaches to these methods in really big groups. But in practice, a lot of it ends up being really informal. We're just having some knowledge of the kinds of techniques and kinds of rules of thumb out there ends up being really great, even if it's, I'm having dinner with Letitia and we're having a chat about the way that she makes music. I still, I'm thinking about the kinds of questions that I want to ask her about, how should this change my own thinking? One thing that I've really learned over the last decade or so is that design tools can be much more powerful than designed tools, right? So much work in the sort of interdisciplinary music tech or arts tech space is about pairing a creator and a technologist, and the technologist makes a thing for the creator. And that's fine, and that can be totally fun. But for me, it's much more fun to build people a toolkit that they can use themselves to design, right? And of course, we wouldn't see a lot of these crazy art projects that I've shown you on screen if it were me or you or some finite number of technologists sitting down next to creators and saying, hey, what do you want me to build for you today, right? The really cool creative projects generally are the result of people having the tools to really do experimentation and exploration over long periods of time to see where they end up, right? Because a lot of the creators you see here, a lot of my students, if you ask them on day one, what do you want to build with machine learning? They're not going to tell you that they want to build the thing that they end up building. And in the sound control project, which I mentioned, this ended up being one of the most gratifying parts of that project. That at the beginning, we all thought that we were going to be working with music teachers and therapists and kids to enable teachers, therapists, and kids to build new musical instruments. That's what I thought we were doing. I think that's what they thought they were doing. By the end of the project, yeah, they were able to build new musical instruments, but they ended up building all sorts of other things as well. Once they had software that allowed them to match gestures to sound, they built games. They built, collaborative jam session environments. They built all sorts of other stuff. And if you're interested in that, again, I've got a 9 paper from a couple years ago. The last reflection, unsurprisingly, is that, yeah, this kind of stuff can be hard. Challenges are inevitable. Everything from communication to thinking about how you publish or fund collaboration-based work, how it gets recognized or not in the ref for tenure and promotion. These are big challenges, and at the end of the day, working with anybody, you're often going to have divergent goals and incentives. I don't have a magical solution to that, but I think it's okay. It's okay. My concluding thoughts for you, I'm just about out of time here. I'll recap, first of all, the lessons I shared with you today, the reflections I shared about machine learning, which is that machine learning usability is not peanut butter. Most usability isn't peanut butter. Computer scientists are wrong about a lot when it comes to machine learning, and human learning is really key to making effective machine learning tools. On collaboration, I talked about my reflections on starting with the right questions and using participatory iterative processes. My belief that design tools can be way better than designed tools, and this is probably what I'm going to be making for the rest of my career, and that challenges are inevitable, but life goes on anyway. So with that, I want to end with 3 invitations to you. If you're somebody listening today and you haven't tried machine learning at all, try it. Now's the time. There are lots of great tools out there. Even if you don't think it's useful for your own work, it's something everybody's talking about. It's not necessarily hard or mysterious. So, go find out what the fuss is about, and you can, approach it hopefully more informed. If you're somebody who makes technology, whether for yourself or in your research, I would say if you haven't collaborated with other creators yet, other people who are doing creative work, try it. See if you can join forces and make something even more useful to the wider world, because it is really gratifying and it's not hard to do. And then finally, I'd like all of you to consider what you can do within your communities, whether that's your university, your academic community, your creative community, to encourage and value the creation of widely used tools. This isn't something that, as I mentioned, always aligns with our incentive structures, like the ref in the UK, or the way that publication happens, or the way that funding happens. But it is something that is really, it's valuable to everybody if you can make something that makes someone's life easier, or allows somebody to do something that they couldn't do before. It's really fun, and it is something that I would like to see us value more explicitly. So if you have some power over that, have a think. All right, so with that concludes my talk. Thank you so much for listening, and I'm looking forward to our discussion.